Hello, welcome to part 2 of Solve Trig Equations, where we will show how to use double angle formulas in solving equations and also the use of a calculator. The next problem has two double angle problems. What you have, if you look at the problem, you have sine of x and you have the sine of 2x. Those are not like terms. You cannot have sine x and sine of 2x in the same problem. So your solution to that is to use the double angle formula and replace the sine of 2x with 2 sine x cosine x. At that point, you can notice that there is a GCF here. You have 2 sine x on this side, 2 sine x as part of that product. And now you can use the zero product property. When you set each part of the product equal to 0, you end up with sine x equals 0 and 1 equals cosine of x. These are quadrantial angles. So remember, you're looking for what places in the unit circle the sine is 0, which would be the y coordinate. So that happens at x equals 0 and pi. And cosine of x is 1, is the x-coordinate 1. That also happens at 0, so that's really redundant. You don't need that. So here's your answer, x equals 0 and pi. Now sometimes students say, well, isn't 2 pi an answer also? But look carefully at your domain. There's a bracket on the 0, and there's a parentheses on the 2 pi, which means that 0 is an answer, but 2 pi is not. Now if you look at the second example of cosine 2x, we have decided to use the 1 minus 2 sine squared x formula because we have a sine x in here and we need to get it to all sines, and that's the formula that has all sines. Now at this point, it's starting to look very familiar to previous problems, so I'll write a few steps and we'll talk about them. Okay, here we have put the equation into order, sine squared sine and a number, and then we multiplied by -1 because it's not nice to factor when you have a leading coefficient negative. So that changed the sign of everything. Of course, 0 times -1 is 0, and factored it and solved. Subtract 1, divide by 2, so we have -1/2 here, and here we have sine x equals 1. And then you're down to the same, this should start to sound very familiar, you're down to the same position where you're finding what x is. It's reference angle 30 degrees or pi over 6, but we want quadrants 3 and 4 because the sign is negative. So we're talking about 7 pi over 6, which is just beyond pi into quadrant 3, and then 11 pi over 6. And I remember that as 7/11. And then sine x equals 1, we're thinking where is the y coordinate 1, and it is at x equals pi over 2. Now so far we have had all familiar unit circle values, and next we'll learn calculator. Now we have to go over how to use a calculator to approximate solutions because they are not, sometimes even in the same problem, you'll have part of it that it's a calculator problem, maybe something like this, -3/7, well that's definitely not on the unit circle, or maybe something that's already a decimal like this. So you have to remember how to find calculator results. And once again, this uses trig knowledge. You can't just use your calculator. Your calculator will only give you the reference angle at quadrant 1, or if it's negative, it'll give you a different quadrant. So you have to just review using the reference angles. Remember, we'll look at the first example first, sine x equals 0.481. The reference angle will always be the inverse sine of the positive of this value, which this is already positive. So this is where your calculator helps you. You get 0.5018. By the way, the book is doing everything to 4 decimal places, so that's the way these answers are written. So in quadrant 1, that is your reference angle. But then to get quadrant 2, it will be x equals pi minus the reference angles. I would recommend that you think through these. Don't try to just memorize, because if you're finding the reference angle or if you're using the reference angle, all the subtractions will reverse and you'll forget which is which. So think of it as think as much as you can on the unit circle. We have a positive sign. We need quadrants 1 and 2. The reference angle is the quadrant 1 angle, so that one's easy. And in the quadrant 2, when you go clockwise, remember you're going in the negative direction, so it's pi minus this little angle to get you your answer. The second example reminds you what to do when your value is negative. First of all, it changes what quadrants it's in, but you also know if you do an inverse cosine of a negative 3/7, you're not going to get the reference angle. So what we had decided to do is find the reference angle first and take the inverse cosine of the positive 3/7, and that will give us our reference angle. That would be the quadrant 1 angle. And then we go through and we need negative cosine to be in quadrants 2 or 3. So for quadrant 2, we are not quite to the pi, we are less than pi, so we do pi minus the reference angle, and for quadrant 3, it's greater than pi, so we do pi plus the reference angle, and that will give you your answers. The third example shows what to do with a tan. A tan equals a negative, so once again we find the reference angle first. We know the negative angle is going to get us a calculator answer in quadrant 4, a negative angle. So we don't want that, so we get the reference angle first. We drop the sign just temporarily and find the reference angle, which is 1.4464, and then remember the negative tangents are going to be in quadrants 2 and 4. So in quadrant 2, we take pi minus the reference angle because we're going back from pi. And then in quadrant 4 is different because we have to use 2 pi and then subtract the reference angle. We're going clockwise again, which is a negative angle direction. So we'll do 2 pi minus the reference angle and end up with the 4.8368. Then one more thing to show you, when you're not going to always have them already isolated. Sometimes you have to isolate. So for this one, you're going to, let me change my color here. You add 1 and divide by 4 and get tan squared x equals 1/4. And remember, we're going to take the square root, but whenever we take the square root of something squared, we remember the plus minus. And once again, the plus minus is going to be your friend. You don't have to do much thinking. You go through quadrants 1, 2, 3, and 4 after you find the reference angle of the positive one, and then I won't talk through it again, but you do all 4 cases to find those answers. Example 8 shows you what to do when you have a quadratic but it doesn't factor. So first of all, you notice it's sine squared and sine, so you have to set to 0, so you subtract 1 from each side. But then we have something that's not factorable. There's no way you're going to multiply anything to be -1 and add it to be -1. So that tells you right away you have to use quadratic formula. Now once again, if it's easier for you to think of what the A, the B, and the C are, if you see, just take out all the letters and use U's instead, that works, but you'll fill in the quadratic formula. I won't go through that. But then be careful. When you get here, I'm going to change my color so it contrasts a little more. Okay, when you get here, notice you have to do the plus and the minus. You have sine x, or u, but it's not x. You have to find x. So you have to put the sine x in back in, and you have to do on your calculator 1 plus the root 5, square root 5. Make sure you hit enter before you divide by 2. And you should be verifying all these answers to make sure you're getting the same things on your calculator. Well, this one's nice because it turns out it's 1.6, and it's not possible, domain error, so you just forget about that whole side. Then you go to the other one, which is 1 minus square root of 5, hit enter, divide by 2, or else use parentheses, and you have negative 0.6180. So that is, once again, just like the problems we just did. You have to find your reference angle to find what x is. So you do the inverse sine of the positive, and you end up with a number which you add to pi and subtract from 2 pi to get quadrants 3 and 4. Now I just wanted to show you that you can also solve simple trig equations using the graphing calculator intersection function. If you're using a TI-84, you would need to be in radian mode, and zoom trig is very convenient because it takes you, the window will be from negative 2 pi to 0 and to 2 pi at the other end. So, and there are regular intervals that correspond to pi values on the unit circle. So it's very convenient, and all you do to do an intersection is take the left side of the equation and put that in y1, and take the right side of the equation and put that in y2, and then do the intersection function, and wherever the intersection points are, that is where your answers are, and you will get the exact same answers as you have gotten if you the decimal answers that you got with the other method. Sometimes you only have a double angle or some other multiple angle equal to a number, and it doesn't help to use the formula because it just makes it worse. So the textbook has a method to do these by hand to get exact answers, which is what you see. Everything highlighted in yellow here is an example of these particular problems, what the textbook exact answer method is, where you start out with what 2x equals, you use the period, and then you divide by what the coefficient of x, and then just keep adding n, whatever it is, in this case it's pi, until you get up to 2 pi. So we're just going to set that aside for now, ignore the yellow highlighted, and look at the green. I wanted to show you, you can also do these using the intersection function on your graphing calculator. Once again, radian mode, zoom trig. The left side of the equation is y1, the right side of the equation is y2, and then you will see this is sine of 2x, the green here, and y equals negative 1/2 is the red line, and wherever they intersect will be an answer which equals the values there, the exact values by the textbook method. And same thing with the tangent, nothing different here, except you have to be more careful with the tangent when you're reading the intersections, because when you're moving left to right, it will often go off the screen at the top or the bottom, so you have to keep an eye on what the x and y values are so you don't get lost. But there you are, you have the power to solve these equations.